This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seberg. Hello, Robert. Good afternoon, morning,
evening,
night, wherever you are, dear listener.
Peter, let's look back at the Siemens AI with Purpose Summit before the main part. We spent 2 days in Munich, set up our studio and met a lot of listeners there.
Yeah.
So what was your highlight?
Well, that was
was the highlight.
Maybe. Well, to be very honest, and you and we are so modest, but then it's so nice that you come in there and you see all these people, and many of them we know, of course, and we do recognize them by face, but then many of them recognize us by our voices, right?
Yes.
You say, you're the person you're Peter, you're Robert from Industrial AI podcast. Now, that's only a very small personal highlight. What was the highlight? I think the highlight was, to be honest, and of course we need to have like this Chinese wall between. We're just reporting on what we were doing there. It was an amazing event, I think. It was a huge event. It was about
500.
It was all about industrial grade AI. There were some specific highlights that we can talk about. Of course, in the first day, the afternoon, we had to talk by Johannes Brandstetter and Albert Ortig, NXAI. We're probably going to talk about that one. You and I, we both moderated the use case session. We can talk about those as well.
Exactly.
But I would say it was the overall event. It was a huge event, a beautiful environment, close to Munich East. It was a great happening.
So I have two favorites. My first favorite was a presentation by Rocket Science on an acoustics and AI in waste management. That was very interesting. And then I said to you, Peter, you should record an episode. Would you like to share 2 ideas or 2 sentences about it?
Yeah, most certainly. So with Katrin Hössli, right?
Yes.
Rocket Science. I had a quick look this morning on their website, but only a very quick. The first thing they say is we do not do rocket science.
That's great.
I think it's a great name for a company to say that's not what we do, but now we have you, and now we're going to tell you what we do. So they do things related to acoustics, sound, and she was there together with Max Schönsteiner. He's from Martin GmbH Umwelttechnik.
Yes.
And they talked about contamination detection with acoustics and AI. And that's what we talked about in the podcast. Very interesting. I think the base idea is, let's say, there's these huge installations where, all kind of stuff that we throw away goes in after, of course, we have gathered the things that we can reuse, glass and paper and stuff. Whatever is left goes in there. And at a certain point in time, I believe there's a heat exchanger, and it becomes dirty and needs to be cleaned. And very interesting. I would have never thought that, let's consider what sounds can do for us. And then they still have to share the sounds with me, I believe. So if you're listening, Max, you told me you're going to share the original wave sources. And then you hear the waves falling down. You can hear the waves falling down. And then you think, what are you going to do with that? Now, what they're going to do with that is that the AI model is going to interpret. You're going to tag the sounds, and the humans are going to say, okay, this is now this and that is that. And then they know exactly the amount of energy actually that has been coming down or in. I don't know in detail. You will probably hear that later on. Very interesting.
All episodes we recorded will be published in the next few weeks, but I have one more question. Do they convert the sound file into an image and then compare the images, or is it really sound-based?
That's a good question that I did not ask. I'm not sure if it's necessary. I think I understand what you mean.
Yeah. That you can see the waves,
Yeah, I'm perfectly with you.
Yeah.
In the book that I wrote a couple of years back, and on the cover there's the bird, and it's recognizing a bird. It's exactly the same. Let me be who's not the professional say that it's the same principle. And at that time I looked at how that is being done. And of course you get a wave. Of course you get a wave of your voice, of my voice.
Exactly.
Now, that's a good question. I don't know. If, Katrin, if you're listening, feel free to send Robert or Peter an email explaining if you go through, looking at the image of the wave and then know exactly what's happening, or if there's another way that actually the model directly recognizes, what's going on. Good question. I can't answer.
We will add that to the episode then.
Yep.
And my second favorite was the presentation by Rainer Brehm. He explained how Siemens developed the industrial co-pilot for engineering and made it robust. And then there was another piece of news, because the industrial co-pilot for engineering will be available for free in summer. That's interesting. And they're partnering with Microsoft, he said, for sure. And then he said, last summer, after the presentation at Hannover Messe, Microsoft changed the model. And they were crazy because, now we started to make it robust, and then they changed the model and they have to start again. And it's very interesting. I'm really looking forward to the episode with Rainer, because it's described with a lot of details how you build now a product out of a AI model for an industrial operation together with Scheffler. We had an episode, but it was more a POC, and now it's getting live. But that's interesting. Yeah.
Now you're still going to do the recording with Rainer, right?
Yeah,
so
I do the recording.
Make sure that you're going to ask him what was their considerations regarding, are we going to ask money for it, or what is the deal? What is the deal? And we had that discussion. I had the discussion with Trumpf as well, right? Are we going to? No, okay, we're going to take the data, and that in case of Trumpf, it was an exchange of data. You recall, it was your. 5 years ago, you said, I'm going to get a free coffee if I give my data.
Yeah.
No, the question is that the initial deal they're going to do? Where at the beginning, we're going to take the data on a kind of a contract, I don't know. And the data is the currency until maybe at some point in time, that's going to be different.
Yeah.
It was very good. It was so good because it was so honest.
Yeah.
It was so honest. This was not a typical corporate presentation, we are the greatest, we're the best.
Yeah.
Anyway, of course, that's what they want to convey, and that's perfectly okay. But it was a very honest showing I think 3 years, maybe 3 years from today.
Yeah.
And showing, this is new for us as well.
Yeah.
And we're going to be very open with you. And they were showing the glimpse they had at Hannover Messe when our chancellor was supposed to be talking to the robot. It didn't happen. That was very, very refreshing, that he was very open and honest with it, and said, there was a mistake that we did. I think the chancellor was supposed to first say hello robot or something like that.
Hello AI.
That was forgotten.
Yeah.
So that was a reference point to him being very honest and open. We're only humans. We are very good, but we have to learn as well, and together with you. And that was very, very refreshing.
What else have you got?
Well, I have two other ones, right? I believe that in the range of you and I moderating the use cases, in total there were about 20, I guess, right? But the very first one on the first day was Christian Gelcher, Embraceable AI. I'd never heard of him. And he was together with Chadi Serhan from Merkle. And they talked about quality assurance for simulation reports, GenAI. And the real interesting thing, which is the big topic for me, kind of, that I've now been following for a couple of weeks, months maybe, is that, they use agents to bring hallucinations down to close to zero. That was really, and I shared one specific approach of combining LLMs with knowledge graphs this morning again. And I see maybe like 2, 3, 4 of them now every day. So this is a huge, very important topic. And Embraceable AI seemed to be like further already in what they had been doing until now than some of the solutions I see today. So very interesting. And then, of course, there was Andreas Kreiner. He's with Pira Innovation. Pira is also the company behind NXAI, which maybe we'll talk about in another minute in a sec.
Yeah.
XLSTM, NXAI. And we did 2 presentations. And the one that I did, you did one with them as well, was building sales warranty dashboards on the fly.
Yeah, that was interesting. Yeah.
And interestingly, that again is on the same topic. And I think you're going to pick that up when you're going to mix the podcasts together. But the core of what, again, he did a very similar thing to Rainer. He was taking us listeners by the hand and says, we're in a proof of concept. We're in the very middle of it.
Yep.
And there is this company and they have, they've said, give us all your the data, whatever data you have, and we have an AI that is going to automatically produce your knowledge graph as the basis. And that, to me, is kind of, is that possible? I didn't know that is possible. And I keep it, I keep the question in the air like that. Is that really possible? And he's open to it as well. He says, is that really possible? But what they have seen so far is very interesting.
Very promising, right?
Yeah, but just because I always thought that what I've been reading from the professionals on the topic of the knowledge graphs, and you have to manage your data. You cannot, the old saying, give me all your data and I can, that is a 10-year-old saying that until now has never really established itself. And the saying that I have by reading more and talking to people is always like, you have to put effort into, and the example I want to share is the same with OPC UA. Many of you know, as in communication architecture, you have to put effort and time into, and if you do that, then you're going to earn the results later on. But you have to. So it's very interesting. Let's stay close to what Andreas learns there. And I did ask him, because they're in the very middle of it. So if they're going to hear the next steps in the next couple of days, they will share with us if it is possible that an AI can, for you, actually organize the knowledge graph.
And next AI, you have seen the presentation. What's your opinion?
Yeah, it was very. This could have gone on for an hour. I did
a lot of
mornings,
questions, right?
They had a normal shot like everybody else, 30 minutes, and it was. Of course, the room was completely packed. I think they could have done it on the main stage, but you never know before. It was amazing. Johannes, as the professor, assistant professor for the moment, I believe, but as the scientist. And it was so nice. You could feel the same way that we have had, Sepp Hochreiter. Whenever we had him, we could feel the tension. And he is exactly the same way. He says he was talking about the big moments of the last 10, 20 years in AI, the 2012 was at NIST, was it 2017 Transformer. He was sharing his own experiences. And he is clearly suggesting this is the same how with XLSTM, it's going to change the world again. That was on one hand, Johannes, and together with Albert Ortig, a very fine, a very balanced managing director of NXAI, who's then answering more the questions on, what is the role of AI and stuff like that. So one I've actually forgotten, if we can also do that quickly. We've heard about a couple of times. Annemarie Schlinkert, Cthulhu.
Yeah.
We've had her together with Eric Schwulera from Siemens. We've heard about what Cthulhu does.
Yeah. Federated learning.
It's the federated learning, right? When I had them in the track, I thought, okay, well, let's see. But yes, I did hear a couple of new things, and they were, for me, they were more in the area of let's say, more solving also potentially globally political problems, because now they work together. And the Catalu platform is there for the Siemens with regards to the electronics, PCB manufacturing around the world. And then Eric gave the example of, you are not allowed to bring data out of China. But now comes in federated learning. You can export model parameters, which is what you do, right? For those of you listeners who are not aware of the federated learning, you don't bring the data to your algorithms centrally, typically in a big cloud. No, your algorithms, they come to the data, you extract the parameters, and then you build your model. And also in relation to even that was new to me, the Data Act. You got to be kind of aware of what it is that you're allowed to do, even within Europe. And you and I should make a podcast on that, Robert, because I think we need to be, I wasn't aware at all. And he said, oh no, you also need to be careful with transferring industrial data. I don't know the details. I try to make myself a little bit knowledgeable, but I think that's going to take another podcast sometime.
Exactly. So let's listen to the host for a moment. I spoke to Boris Scharinger from Siemens. What is his opinion on the AI with Purpose Summit? So I recorded, I think, 2 or 3 minutes. Let's listen.
But I can tell that I heard a lot of good things about the intrinsic presentation on the future of foundation models for robotics. And I heard many, many great things about the update that was given by our NXAI colleagues from Linz, right?
Okay, that's research, right?
Yeah.
Let's talk about a use case that inspired you, because we had a own session about use cases, and we in the Industrial AI podcast always talk about research, about academia, but we want to talk about use cases to learn something from use cases. What was the most interesting use case you saw?
For example, Safran Analytics presented how they approach AI-based testing in their production. And what I found pretty amazing is how statistically driven they were trying to frame what can ever be the prediction quality of the solution that we build, right? And they had a very analytical approach and said, given the data points that we have, given the size of the data sets, given the features, we will not make it above a certain ceiling of prediction quality. And this tells me that there is a fundamental passion and drive, not fancy, right? They were telling us how far they could go and where they struggle to kind of break through that model performance ceiling. And that is very decent, that is very grounded, that is very analytical. And this is exactly, from my perspective, what we need to mature AI than to become industrial grade. So I found that fascinating as an element of perfection and ambition.
Yeah, that's very interesting. Let's have a quick outlook next year. What is your plan?
Well, first of all, the plan is to do it again.
Okay.
And of course, we are collecting a lot of feedback. We understand what we can improve a bit. And we are now in discussions internally, and probably need a couple of more weeks for that. Do we scale further, right? When we started...
scaling is... It's all about scaling.
When we started 2022 with the first instance of this conference, we started with, was it 160 people or a bit more?
Yeah. Participants.
And then we doubled in 23, and now we more than doubled, right?
Wow. So scaling the event is a goal, and maybe also scale AI solution is the next step for the industrial. We are very excited what happens next, and we are looking forward to the next year. Peter, let's move to the main part, because I recorded an episode with Shahroz Khan from Bar Technologies. I've never heard this company, but it's a company based in UK, and he's the lead of R&D. They are in this ship designing business. And you said, okay, ship designing, that's not interesting, but it's very interesting because Shah shares how they generate data for new designs with GenAI. And this should also be of interest to our mechanical engineering company because it's synthetic data and it's real data, but they had not enough real data, and then they generate data. Very interesting. It's chip design. It's a totally different branch, but very, very interesting. Yeah,
I haven't heard. I'm looking forward to it. Yeah, sure. I mean, that's the approach I will have as a studied architect. The same, the architect, I guess, globally, if I may be so modest, probably was the first 2,000 years ago to bring a model, right? It's always about, and modeling simulation is always looking into the future, right?
Yep.
It's like you yourself as a person who wants to do so. Sure, all of us who have the capabilities say, I want to build something, I want to build a house. And those of us that are more creative, they have their own ideas. Those of us who have not, since 2,000 years, they go to an architect, and he or she has the capability to get a look into the future. Now, if it's now about a new machine, if it's about a plant, if it's about a
ship,
a complete production line, or a ship, I can very well imagine that what we're going to hear in the main session is going to be interesting for all of us.
He said ship design didn't change over the last 30 years. A tanker is a tanker, and still they have the same design. And now they are capable to design new ships. So it's very interesting.
Right. Yeah. Okay, so we're back now to Hannover Messe 3 years ago, 4 years ago, where we had at Festo stand,
Jan
and we had Jan said, in a couple of years, and we then taught reinforcement learning. But the idea is always the same. Doesn't matter if we call it reinforcement learning or whatever the algorithmic approach is. Let's put it like that.
Yeah.
Soon the algorithm's gonna help, or gonna design them for us, and that's what I assume, and I'm looking forward to, are going to show us many different options, and we can choose from them. Right.
Thank you, Peter. It was a pleasure.
Robert, thank you very much. Have a good day. Going back to our more normal work, and dear listener, hope to have you with us soon again.
Bye-bye.
Bye.
And my guest today is Shahroz Khan from London, and we talk about the design of ships and how AI and GenAI are changing it. But before we start, why don't you briefly introduce yourself, you and your company, Shah?
Thank you, Robert. Thank you very much for the introduction. My name is Shahroz. I'm an R&D Lead at BAR Technologies, which is a simulation-driven maritime innovation company. We work on developing various energy-saving devices which help to reduce fuel consumption, thereby CO2 emissions in shipping. And one of our leading product is Wind Wings, which is a wind-assisted propulsion system. That system helps to reduce fuel consumption around 1.5 ton per day. That replicates towards approximately 5 tons of CO2 savings.
But before we really get going, we are not talking about a product today, but about a look into the near future, about corporate research, right?
Yes.
And we want to talk about ship design. I don't know the industry. I don't know the challenges. Tell us, how does the industry work? What is so special? And what are the problems maybe, or the homework this branch has to do?
Absolutely. Robert, would you like me to give up? Because I have a story myself, that how I went into this field, like how I faced the challenge, how I get into it. So by training, to be honest, I'm a mechanical design engineer. I went on becoming a yacht designer. That was the first time that's back in 2016 when I started looking like how machine learning could be adopted towards better designing yachts more efficiently. And then I went on doing a PhD in marine engineering. The entire process or my career development was really driven by the problem that I first saw. Like maritime industry seems to be, or considered to be, a bit of conservative industry. We don't have the pace that is followed by automotive and in aeronautics. But we all know,
when it comes to design, when it comes to new models or new designs, right?
Exactly. But as the new regulations are coming into place for reducing CO2 emissions around the globe, And we all know that water transport is responsible for approximately 90% of global trade. And in 2020, global shipping itself emitted approximately 1.4 billion tons of CO2. Can you imagine such a big scale?
Yeah.
And within that accounts towards 3% of CO2 emissions globally. So to tackle that, International Maritime Organization, which is a part of a bigger organization, they have placed various metrics and regulations for the shipping companies to reduce these emissions. So their target is by 2030 to reduce these emissions by 40%.
40%? Wow.
Yes. Whoa. It's a big challenge, but I think we have a roadmap now that we can achieve that, or we can closely achieve these goals. But so far, the trend has been that how these aims will be materialized, that as I said, like similar to my company, Bar Technologies, we're developing energy saving devices. So this is a very specific term that we use in maritime industry. So energy saving devices are those devices that we can retrofit on the existing vessels to reduce fuel consumptions, thereby reducing the CO2 emissions or greenhouse gas emissions.
Okay.
So these methods or these technologies have worked very well. But in the industry, we know that 90% of the overall project cost is accounted by the decisions that are made at the early design stage. Okay. And through the studies, it has been also realized that 90% of the performance efficiency can be achieved really at the design stage. And however, even with such reductions that can be achieved at the design stage, we don't have tools, right? Set of tools to design effective ships or effective vessels.
Why are there no tools?
Because, as I said, like the shipping industry has been
conservative.
Still bit of a conservative look. So, for example, the designs that you will see, which were like 100 years ago, and the designs that are today, they still have a strong correlation between them.
Absolutely, yeah.
They are not significantly deviating. Well, that approach, let me tell you like how a typical ship design process started. So you are a ship design office. A customer comes to you with set of design requirements that I want a vessel which has A set of requirements, B set of requirements, C set of requirements. You will go towards your existing database. You will take a baseline design. You will update that design through an iterative process to match these new requirements, and until you approach a satisfactory design. So everything starts with the baseline design. And all those baseline designs were developed in the past with this conservative or narrow design spaces. So you don't have a freedom to really explore aggressively different designs. That was the problem that I came. And then I started to explore, like, are there existing tools to actually help this diverse design exploration towards designing more efficient ships? The question was, no, there are not that such tool. And the problem came back in 2015 when there was a first paper by Aon Goodfellow on generative model, who I would say who reintroduced this approach for creating realistic images of the people that doesn't exist.
It was 2015 you mentioned, right?
Yes, that was the paper. I remember I read that.
But you talked about machine learning, and you have been working on the topic for some time. And then you realized, oh, there's a GenAI approach. Or please explain.
Yes, exactly. Okay. So the problem was machine learning has been used a lot in the industry back in, let's say, 2000s. But that was mostly in engineering, the efforts were centered around how you can predict the performance, which has worked very well. So, for example, previously you would have to run large amount of CFD simulations, which are computationally expensive, time consuming. And then you will bypass this simulation process by building surrogate models using machine learning or other statistical approaches. But in this case, the problem wasn't predicting the performance, because you can only predict the performance if you have the design, right? If you don't even have the design, how can you predict the performance? And the designs that you existingly have, they are almost similar to each other. There is not a margin for creating widely diverse shapes. So how can you do that? How can you create design spaces which are extensively vast, can able to create multi-purpose, special purpose vessels, and simultaneously they are very efficient in terms of their fuel consumption and their emissions. Okay? So that really drove the efforts that how we can create these tools.
And then that was 2015, right?
Yes, exactly. Okay. And that was the time then I felt like, okay, there is a nice gap and I would really like to get into this field and try to see how we can overcome these gaps. And then I did not start right away on that problem. I started my PhD in 2020 and as a Marie Curie fellow, and the research team I joined, they also had a similar problem. So whenever they would have to design a vessel, they will go select a design, they will parameterize a design.
The standard design.
Yes. And then take this design and then further refine this design until it achieves given design specifications and the requirements. So every time there was changes in those requirements, we will have to repeat that process again. So you would have to reconstruct the design, parameterize it, evaluate it, and then reach to a design which satisfies the new requirements. So we wanted a tool that was generic, so it could able to design not only one type of vessel, that's like not only container ship, cargo vessel, or yachts or something. That tool was generic enough to create any type of vessel. Okay. And also able to create those multi-purpose and special build vessels where the industry struggles a lot. So for that, we need how we could do it. So that idea, as I said, like back in 2015, when I wrote the first paper on generative adversarial networks, I was like, okay, 1 second. With the right amount of data, if we can create images of people that doesn't exist, can we do the same? Can we use the design data of the ships and create a model which will be able to create the shapes which, quote unquote, doesn't exist?
And how do you give the design the requirements?
That's a very good point. So the biggest challenge in constructing that model was first, where do we get the data? We all know that the number of ships are not as many as the number of people on the planet, right? And second, the shipping industry is not as open as automotive industry. You don't get the design data laying out over the web.
Oh, that's a pity.
Yes, that's very pity. So we had to spend almost 2 years in terms of creating a data set that would be vast and diverse enough to create that generative model for ship design.
Is it only scientific data or is it real data?
Yes. Another point that's a good point. We try to add both type of data, both the real data and the scientific data. So the scientific data, because there are certain designs that are validated by several research institutions like Marin, Netherlands Maritime Research Institution, or Italian National Research Council's Institute of Marine Engineering. Those have validated these designs for experimental purposes. But most of the time, these designs also act as a basis or as a baseline design in the industry too. So we gathered that data and then we end up having approximately 17 different classes of designs. And we all know that 17 different data points are not enough to create a generic generative model.
Sure.
So we had to come up with the approach like how we can further extend it. And then that was the point that we couldn't exceed more than these designs. We came up with an idea that we could create an augmented data or synthetic data by manually creating different variations of those 17 different designs that represents 17 different classes, including naval vessels, oil tanker, cargo vessels, LNGs, yachts, offshore sports system vessels. And then because another problem that we came at that we cannot pass everything into the model, because if we put something unrealistic into the model will always able to create unrealistic design. So we had to develop some filters to make sure that always a good data is passed into these models. So the models are reliable in terms of creating designs and geometries and matching the requirements.
Okay.
So we created two types of filters. Like one was a performance filter, another was a validative filter. Validative filter was how we can validate these designs based on the geometry. So is the design has, for example, good geometric representation? Is it watertight? Is it not self-intersecting? And the second was what's the performance of design? Can we evaluate the performance of design, or is it good enough for that? So by passing through these two filters, we came up with approximately 50,000 designs variations.
Wow. Okay. Shah, one question. So when we talk about design, we talk about simulation and stuff like that, and we are talking about moving parts. I think that's the most critical part, right? Because you can have data, but we talk about moving parts when we talk about cars or ships or machines or motors. Is this the most problem when generating synthetic data, that we talk about moving parts?
Yes. I mean, another problem that relates to this question that you asked, that these generative models have been used a lot in computer graphics community. So where the aim is to train the model to create variations of 3D objects. But in our case, by an engineering problem, the aim is not just creating the variations, but creating the models which are physically validated or viable.
Yeah.
Those who have certain degree of feasibility. Because, for example, if this generative model created a design which have a slight variation on the surface or less smoothness on the surface, so the physics for that or for those two models will be completely different, right? Because these designs have to be operating into the real life conditions, right? So the aim is not just creating shape variations, but creating shape variations which are viable, feasible, and takes into account different operating and manufacturing constraints.
And how good is your data set now?
Right, that's another question. So once we passed through that model, we got a reliable data set, right? The second thing is
how you measure, is it reliable?
What I said earlier, we introduced two performance filters.
Okay, yeah, sorry. Yeah, right? Okay.
Yeah, so one to check the validity of the shape. The second is to check what's the performance of that specific design. Yeah. Okay, so we removed bad performing design, we removed invalid designs or infeasible designs, and then we came up with this, and the exact number is 52,490 design. That's what, when people ask me how you came up with this exact number, I tell them that's where this exact number comes from after passing it through performance filters. Now, once we get the reliable data, and now we're going to train the model, right? But as I said earlier, this is not a problem of a computer graphics community where the objective is to create synthetic variations or variations of an existing shapes, but we have to make the model somehow physics informed, because these designs resulting from these models will be used in real life, right? So how do you do that? Physics. Okay. So there is a new type of models was introduced back in 2019 called physics informed models. So the aim here is that while you're training a machine learning model, you take a certain part of your physics, you add it into your loss function or objective function during the training. So the model learns a more of a compact representation of the physics also. And that's what the word comes about, physics informed. So the model is physics informed. Although these models have been used widely, but in our case, we took a slightly different approach. We had a problem that, we want to infuse physics. We could do it in that way, but we came up with a slightly different way. And in our case, for that specific application, worked very well. We developed geometric operators based on a ship drag and resistance, or in generic term, you can say performance theory, that was introduced back in 1930s. And then with using that theory, we developed geometric operators. So these geometric operators, they act as a basis for evaluating the physics in our case, drag as the ship moves through the water, but they're not computationally as expensive as evaluating the physics itself. For example, a high fidelity CFD simulation to evaluate the drag or resistance of a ship could easily take 2 to 3 days. And imagining doing that for 50,000 plus designs, that would take forever. So we developed these operators, which holds a lot of information about the physics, but they are computationally cheap to evaluate by 90% in terms of computational cost. We took those models, and took those operators, fit into our model, and then trained that model. And from our testing, we realized that this model, we could use not only to optimize the existing type of designs, but also to create new type of designs. For example,
what I'm interested in is, now I'm the shipbuilder, and how do you give the design requirements then to the model? Do I have to write a prompt or something, or what is the idea?
So the idea here is that we have converted that model into a function, like a library.
Okay, perfect.
And it starts with two set of different parameters. The first parameter is the design constraint. How much volume that design should hold, what should be the overall depth, length, and the width of that design. And which we call it bounding box. So once you define your bounding box based on your requirements, like for example, if you're designing a container ship, then you would say like how many containers approximately that vessel should able to hold. And then you define that number. And then based on other constraint that typically comes from customers, for example, if the vessel has to pass through a Panama Canal, then it has a certain limitation, how much width or the breadth it can has, how much width it can has. So all these constraints, the model takes it. So these are the predefined constraints or the requirements the model takes it. And then within these constraints, the user has two possibilities. So the user either says the model, okay, find me n number of design which satisfy all these constraints, including the performance one. For example, the user wants performance to be between this and this range. Mm-hmm. So the model will come up with various different designs satisfying all those design and performance constraints.
Design means there's a visualization then?
Yes.
Okay.
So these are actually like 3D surfaces of the designs.
Okay. Mm-hmm.
And then from there, user can select a one that best matches the requirement or matches all the requirement, and then take the design as a baseline to further develop, because there are several different constraints and the designs that are kept in mind throughout the development process. So that right now the tool has the ability to take into account certain set of constraints and requirements, but not at a very holistic level. This is something that would need further developments.
Mm-hmm. And does the model continue to learn when the designer changes something?
Yes. Mm-hmm. So there are two venues for that. Either the designs that are coming out of the model, some of them can still be, let's say, infeasible from a side. For example, it could have like very sharp changing in the shape. Okay, so that from the manufacturability point of view, this could be not possible. You don't have to run detailed analysis to identify that, where an experienced designer can directly tell you mm-hmm. that. Mm-hmm. Okay, so this information can go back to the model, and then from that information, model can run. Okay, I understand that these type of designs are that this typical user is not interested in. So in the future exploration for that typical user, the model won't provide that design, but this have to be more into the details of the model, where the user would really need to understand like how to program it in a certain way that it won't give us these type of design in the future.
Mm-hmm. When we talk about design, we talk about intellectual property also. How difficult is it now to manage intellectual property and a design solution by a GenAI approach?
That's a very good, difficult, and I would say like hard question to answer.
Yeah.
So right now, this tool was the outcome of my PhD. There has been several industrial partners, including my company, where I'm currently working on to see like what these tools could give us. Right now, I think it's still at the development stage, where a lot of different aspects of research needs to be done and needs to be in place to have, let's say, a holistic level of maturity for such GenAI tools in shipping.
Yeah. But what do the shipbuilders say? Are they happy or?
As I said, like for shipbuilders, it still needs some time to really have a look in terms of adaptability. Mm-hmm. They are interested in seeing, let's say, like such designs can be possible. There is such a tool there, as I said, but from the shipbuilder point of view, they are still hesitant in adopting such approaches because, as I said earlier, there's still need of a development there. Sometimes model will come up with a solution where it's different from performance point of view, it's performing well, but from manufacturing point of view, it may not be feasible to construct, right? Or it may be a bit expensive to build. So these type of constraints, those who are a bit more subjective and require, I would say, expert level details, would need to be extracted and put it into the model. We have actually the project, it's funded by a UK research organization that will work into this aspect, like how we can incorporate in this model, like expert view on the designs.
So the domain perspective, domain knowledge.
Yes, exactly. The domain knowledge that has to be integrated into the model itself. So I mean, like the broader vision would be imagining a similar system like Gemini or ChatGPT, but really focused on designing ships. For example, user goes towards that. Okay, it says like, okay, I want to start designing a ship, which is a container vessel, which should have this much capacity, which should have this constraint. Systems come up with design. And then system pass it towards a surrogate model, which evaluates the performance of all those designs. And then system says, okay, you know what? Designing is one part and maintaining the regularity constraints and the operations another part. Then system takes from there towards the operational part, where how to analyze like that specific design, how it will perform if it was in a specific ship route. Okay. If that design, while it's voyaging on that specific ship route, does it satisfy the regularity requirements or not? And this type of system, which have like that type of holistic projection, would be of great use.
Yes, absolutely.
As I said earlier, so this is just a phase where we wanted to see like, can Gen AI could be used to create designs which will be viable in next 50 years or 100 years.
Shah, it's very interesting because my question is now, what can other industry learn, especially when it comes to the development of your data set? I think that's really interesting. What is your opinion on that?
I think we could, for industry itself, like they, for example, bigger industries, let's talk about automotive.
But they have a lot of data, right?
They have a lot of data, as I said, like the variations, because to best create these models, you need to have a diverse data. Diverse data, so the model can able to generalize variations between the designs. And they already have a lot of data. I think the only thing is they have to understand like how this model works and how they can use the existing data in their organizations to train these models. I mean, I think most of the industries, when it comes to adopting machine learning, AI, or now Gen AI, is that they don't realize that they may have that data that they would need in terms of creating these models. So they don't have to work further on developing the data sets.
But really like your approach to develop or to generate synthetic data. That was very interesting, I think. And that maybe is a blueprint for other industries. Or am I wrong?
I think 100%. I think synthetic data it's not an approach that was only followed by us, but in speech recognition, in image training, in video decoding, there's a lot of cases where we have seen like the performance can be further increased, especially in the cases where the availability of the data is an issue, like in our case. So the creating synthetic data can really help.
Yeah, but I think it's so important when we talk about industrial use cases and we talk about synthetic data, that's a totally different field, you know? When you talk about speech or language, it's also a different field because, as we mentioned before, we are talking about moving and we are talking about movements and we talk about moving parts in the simulation and at the end at the vessel or at the machine, right?
Yes, exactly. As I said, like we are borrowing this tool from this community. Like in engineering, we're borrowing this tool, but now the trend has changed that we are, instead of just borrowing this tool and using them as a black box, we are updating them to meet the requirements within the engineering, within the design. So for example, one example I gave is physics informed model. Right? So instead of training just on a very specific loss function, you actually integrate also some component of physics into that loss function. And we have seen the cases where sometimes model can predict or at least like help you predict or drive the performance without even needing some data because it's just relying on the laws of physics. So that's some interesting examples. And I think like in Gen AI 2, where the problem is not only to predict the performance, but actually to create design itself.
Exactly.
So these type of, let's say, like integration would be also be essential, I would say, for creating some viable models.
Shah, you already mentioned what are your next steps, but what will be on your desk tomorrow?
To be honest, like I
have holiday.
I wish I had enough time to work on this model on further. But I think like in the future and the team that I was part of during my PhD, they are working currently on further enhancing and developing this model and trying to see, let's try to also educate the industry first. Yeah, I think it has showed some progress. It has showed some potential, but I think roadmap towards industry, it still needs some time and some motivation in adaptability by the industry.
Mm-hmm. But your company is not pursuing the topic.
My company is not currently pursuing the topic because we are in the process of developing something different. But the long-term future is that we're gonna look into it in adopting such approaches and the techniques in our tool or device development.
And what are your plans? Can you share it with us?
For example, one thing from the generative modeling point of view, we are working on how we can expedite over existing design pipelines. Mm-hmm. So for example, if an optimization process takes, for example, 4 months to complete from getting customer requirements towards providing them the final solution, how we can expedite this pipeline, this process through using machine learning, deep learning, and GenAI.
Mm-hmm. Well, if I want to know more now, which person do I need to contact? Who's working on this model? Is it a special university? Is it a special research team? Who is working on that? You mentioned the funding from the UK government or something. Who is working on that model?
Right now for that model, my professor, Dr. Panagiotis Kaklis from University of Strathclyde at the Department of Naval Architecture and Marine Engineering. It's one of the biggest marine engineering department, not only in UK, but in the Europe. Mm-hmm. They are currently working on that. And they have right now a collaborative project between MIT, University of California, Berkeley, Imperial College London, Marine, which is a leading maritime research institution in Europe. Yeah, they are in the process of bringing different industrial and academic and research institutions on board to further develop this model.
Would you say that you have started to discuss marine design foundation model?
What do you mean by design foundation?
Would you say that you, in your thesis, started the discussion to build marine design, ship design foundation model? Do you start the discussion?
Yes. I would say yes, in terms of providing or proving the feasibility or usability of such approaches for industry, which is already lagging behind compared to others. I think we have done a very good job and then providing a very realistic look on the feasibility and usability of these models into ship design. As I said, their integration and adoptability in the industry would need some further development and encouragement by the industry. And I'm happy to be saying that the marine industry currently is an amazing place to be. Mm-hmm. Although that was adopting the new technology into this industry was, I would say, with my very limited knowledge, that was driven by strict regulation by International Maritime Organization. But right now, I feel like there is a hunger from this industry in really getting some novel technologies on board. Currently, as I said, this is done to make the existing vessel efficient. But in the future, as we will be building new ships, the customers, the industry will be looking forward such approaches.
Shah, thank you very much for your insight into your work, the marine industry, and all the best for you, your company, and greetings to London.
Thank you. Thank you very much, Robin.